the tan graph is an entirely different animal compared to the cos and the sine graphs, which are really similar to each other. The tan graph's really special. And the way that you're going to remember the shape of the tan graph is that it is a water slide in between two poles. Now you'll remember from the hyperbola graph and the exponential graph that there are these things called asymptotes, and these guys are asymptotes. Okay, so I put a table down. The first time you draw a tan graph, you should work from a table, but thereafter you can just recognize the pattern and draw it from there. When you do this on the calculator, this one's a lot longer than the sine and the cos graphs, and it's because you need to go up in 45s. Okay, because some of these are going to blank out, some of them are going to go math error, and I'll tell you which ones they are now. This one's going to be a math error, which means it's an asymptote. Okay, this one will be a math error, it's going to be an asymptote, and also this one, and also this one. So between negative 360 and positive 360, there's going to be 4 asymptotes. So when you plug this into the calculator, you're going to get math error on each one of those. Okay, for the rest, I'll fill in those numbers now. So what it has in common with the sine and the cos graphs is that it still really only goes between 0, 1, negative 1, and then there's all these asymptotes everywhere. So when you have asymptotes in a graph, like the exponential and hyperbola, draw them in first, because it helps you with boundaries. It helps you to understand where else you're allowed to draw, because clearly on the asymptotes you're not allowed to draw anything. So I'm going to fill in at all the asymptotes. I'm going to fill in my dotted lines here, and then I know that I can't draw anything that crosses the asymptote, because the asymptote is the don't touch me. It's the line through which nothing else may go. Okay, so I've given you the picture already. It's going to be a water slide between two poles. You can see it's going to do that. This one's not symmetrical about the y-axis because it's actually going to go through it. Okay, now we're going to plot some points, and then I'm going to show you how to connect them. So on negative 360 it's a 0, and I'm just going to plot all the zeros so you can see where it goes here. Negative 180 is a 0, on 0 it's a 0, then on 180 it's a 0, and on 360 it's a 0. Just want you to see the pattern. Okay, so you can see that it's going to be there. So I'm going to have something that goes like that, it's going to cross over, and there's going to be some little tails at the bottom and the top of the water slides at the top. Now let me plot in my 1s and negative 1s. So on negative 315, which is between negative 270 and negative 360, it's that little one there, then that's going to be 1. So you can see the shape is going to go there. It's actually not going to finish. It's not going to be a complete water slide. Okay, then if I go further on negative 225, which is in between 180 and 270, it's negative 1. So you can see it's going to go like that. Okay, and I'm going to fill in the rest now. Right, so what you can see is a series of what looks like diagonal lines. Now, just to make a point, I want to show you what happens if you enter in a number that gets you more or less 2. Okay, so if I take on my calculator tan of 63 degrees, I get 1,96, which is really close to 2. I just want to show you, if I plot that, how it helps me understand the shape of the tan graph. Okay, I've got to approximate here. If that's 45, which is in between 0 and 90, then more or less a third of the way is going to be about 60. Okay, so if that gives me about 2, look at that. It certainly isn't going to help me with my diagonal lines. You can see what happens here is that shape curves, and it's going to do exactly the same in each one of these water slides that's in between the two poles. So the way we're going to join them is bearing in mind that asymptotic. So you can see this one is only covering 90 degrees. It would need another 90 to get its other shape in, and we're not going to finish it. So what happens to each of these sets of 3 is they do what all graphs do by asymptotes. They try to get really close to the asymptote, but they never get there. So that's how to remind yourself what an asymptote is. So this graph looks completely different to the sine and the cos graph. And you need to remember to curve so that you get the right shape. There's also something really different about this graph. One shape is one water slide between the two poles. So you get an entire tan graph in that amount of space and another entire one there. This one's easy to see. How many degrees are there between 90 and 270? It's 180, right? So that means that the tan's graph has a period of 180 degrees because it only takes 180 degrees to finish an entire shape. And that's also what makes it really different to the sine and the cos graphs, who have a period each of 360 degrees.